All right, today we're going to cover a short topic on energy and how it's connected to temperature. So first off, all year we're going to be talking about the law of conservation of energy. So energy is always conserved, so the total energy is always going to be constant. Energy is never created or destroyed. It can change from one form of energy to another, but again, it's always going to be accounted for even from a transfer. There's two big categories that we're going to focus on this year: potential energy and kinetic energy. So potential energy is stored energy. It's energy that's not doing work right now, but it has the ability to if it's released. We'll talk about this a lot this year when we talk about chemical bonds and the potential energy involved with bonding. We'll also talk about potential energy when we talk about phase changes later this year. There's a variety of other types that you'll deal with, not just in chemistry, but next year in physics. Kinetic energy is the other big topic, and we're going to focus on that this unit. It's the energy of motion, and it's contained in anything that moves. So we're going to be talking about particles that are moving and the kinetic energy that they have. Some big types that are related to kinetic energy is thermal energy, electromagnetic energy, which is light, is one example of the spectrum, electrical energy. What we're going to focus again on are the particles. So as atoms and molecules and other particles of that scale gain potential energy, their particles move faster, and thus the temperature is going to increase. One thing to note is that potential energy can be changed into kinetic energy, and kinetic energy can be changed or transferred into potential energy, but the total energy is always going to be conserved. So like I mentioned, we're going to focus a little bit on kinetic energy and specifically how we can measure the amount of thermal energy. So temperature is a measure of the average amount of kinetic energy possessed by the particles of an object. So it measures how fast or how slow the particles are moving. So we have two main scales that we use, Celsius and Kelvin, and we're going to focus on converting between those two. Kelvin is set to the lowest mark being 0. The 0 point on that Kelvin scale is known as absolute zero, and it makes sense in terms of realizing that temperature is measuring how fast the particles are moving. So the lowest temperature that can be achieved, absolute zero, essentially the particles have stopped moving, they have no kinetic energy. And that's how they kind of arrived at that scale. You're going to have to be able to convert between Celsius and Kelvin temperature scales. So in your reference tables, you have this formula. So we're just going to do two examples of converting between the two. And usually the easier one for students is when we have degrees Celsius and we have to find Kelvin. So we're going to simply plug in the 21 degrees Celsius into the formula. We're going to add 273 to it, and we get that 21 degrees Celsius is equal to 294 Kelvin. If we have to convert the other way, such as when the temperature is 300 Kelvin, what is the temperature in degrees Celsius? We're going to plug in 300 for K. And then this is where you're just going to be careful with your math steps. You want to make sure you subtract 273 from both sides, and you'll find that X is equal to 27 degrees Celsius. So 300 Kelvin is equal to 27 degrees Celsius. So just be aware of potential and kinetic energy. Be aware about how temperature is a measurement of average kinetic energy, and how a way that we can measure thermal energy and how fast or slow the particles are moving.